Okay, peeps, this is the energy calculations that you can whiz through if you need any support with the energy calculations in the energy resources booklet. So, question one is state the true calculations for calculating efficiency. So, number one, efficiency is equal to the useful output energy. It's divided by the total input energy. That gives you the efficiency. You may be asked to express it as a percentage. If that's the case, then you would just multiply by 100 to give it as a percentage. The second way that you can express it is, or maybe be asked to calculate it, as if you were given power. So useful power out divided by the total power input. Now it's important, and again you might be asked to do that as a percentage, which means you would just multiply it by 100. It is really important to remember that it's the useful power output or the useful output energy divided by the total input. If you get them the wrong way around, you will get an answer greater than 1 or an answer greater than 100. If that's the case, you know you've done it the wrong way around. Question 2. A device, calculate the efficiency of a device that has a power of 90 watts and a power out of 54 watts. So it's a long equation to write out again, so I will just use the numbers in relation to the equations up here. So the efficiency, we're saying that it's 54 watts of a useful output, and there is an input of 90. So that is 0.6. That's the efficiency. Now I could convert that to a percentage. We should be at a 60% efficiency for that device. For question 3, we're calculating the efficiency of a machine that is supplied with 800 joules and it wastes 280 joules. So you've got to think carefully about this one. So it is supplied with an input energy of 800 joules and it wastes 280. So the wasted energy of 280, we need to subtract that from the input energy to work out how much is actually useful. So that is 550, 520 joules, which is useful. The 280 was wasted, so the efficiency will be the 520 useful divided by the 800 input, and I like doing it as a percentage. Which will give you an answer of 65%, I believe. Question 4. Work out the efficiency of the following device as a percentage. A device where the total power in is 36 watts and the useful power out is 12.6. So this is using power this time, so it's the same thing. So we're getting 12.6 out, and we're putting 36 in. And if we express that as a percentage, we're getting 35% efficiency, which is not good. That's a lot of wasted energy. Number 5, we are calculating the work done by an electrical winch that lifts a car with a weight of 15,000 newtons by 12 meters. So work done is the force times the distance. So the work is the 15,000 times the distance of 12 meters. That's quite a large height for a car to be winched, but never mind. So that's given us a work done of 180,000 joules of work winching it to that height. So question 6 is a bit of a challenge question for us. The motor of the winch in the above question has a power usage of 9 kilowatts, and it takes 30 seconds to raise the car the distance. Calculate the energy transferred by the motor. So energy is power times time. So the energy used will be the power of the motor, which is 9 kilowatts. So remember that needs to be expressed as watts, so that's 9,000 watts. And that takes 30 seconds. 30 seconds. So that would be 270,000 joules of energy used by the motor. So what we're being asked to do next is then to take a look at the efficiency of this energy transfer, comparing our previous two answers. So we can see that what the electric motor put in was 270,000 joules of energy, but the work done lifting the car to 12 meters was 180,000. So the efficiency will be the 180,000 divided by the total input of the 270,000. It's given us basically an efficiency of, this rounded up, 67%. Question 8 then is asking us, well, why is it 67%? Why is it not 100%? So basically there will be energy dissipated to the environment as heat. Okay, that's going to be due to the friction of the moving components of the winch and the, I guess, the hydraulic components. There's surfaces rubbing together, generating friction, and that causes us to lose energy to the surroundings as heat, which happens with most energy transfers. You will see in working through this booklet, you'll be asked to think about lubrication. One of the ways that lubrication will reduce the energy transfer will be to reduce the friction between surfaces, and we can reduce that. 67% is quite good, which would suggest that this winch is probably reasonably well lubricated. Thanks again for watching. Have fun with the rest.